All right, sixth graders, these are the notes for 3.1, the engineering design process. And I know that you've talked about the engineering design process a little bit back in elementary school, but the engineering design process is a process that engineers or anyone who's engineering goes through to come up with a solution to a problem. So our objective is I can explain how the engineering design process develops solutions to meet people's needs. And our essential question that we need to be answering by the end of this is, what is the engineering design process? Here's some vocabulary, and you might want to pause the video so that you can record that down onto your notes. Science is the study of the natural world. Technology is the application of science for practical purposes. And engineering is the application of science and math to solve real-life problems. So science, technology, and engineering are all related. However, they are three different things. Basically, engineers use technology and they use science in order to solve problems. A trade-off is the act of giving up one advantage to keep another. And a prototype is the test model of a product. So you might want to pause so that you can get those down. All right, part A, what is technology? Well, technology applies science for practical purposes to solve everyday problems. And technology can include products, processes, or systems. And the engineering design process is used to develop new technologies. So some technologies that we think about, I know a lot of you, when you're thinking of technologies, you think of like a computer or Chromebook or an iPad or a cell phone, okay? But technology can be something as simple as a pen, okay? Or as simple as a zipper, okay? Because all of those things were invented at some point in history to solve an everyday problem, okay? And then also on here is a catapult, which you either did this yesterday or you will be doing it tomorrow, where you are creating your own catapult. And that's why we added that in there. It's kind of fun. Is all technology complicated? And so this is when we're talking about an iPad or computer or cell phone. A lot of times we think of that as technologies, but not all technology is complicated. Okay, so technology can be really simple, and an example would be a zipper. So zippers are simple to make, they're inexpensive, and they require no electrical energy to operate. So those are the three notes that you're writing down under technology can be simple. They're simple to make, inexpensive, and require no electrical energy. Technology can be complex, so computers, phones, etc. And these require a complex knowledge of science. They use electrical energy, and they're often expensive to make. So those are the three notes you write down for the technology can be complex. Part C, what do engineers do? Well, engineers use science and math to solve real-life problems, okay? So one of the things that they do is they apply science and math by conducting research. They may improve on a solution that was used before, or they may build a new solution. For example, when we look at like the development of the pen, okay? At first, people used to dip feathers or quills into ink and write with a pen. And eventually, we ended up with pens that have ink inside of them. Okay, so we can kind of trace the development of things over time. Another example is the iPhone, right? They keep coming out with new cell phones and more advanced cell phones. They can do more things. Apple comes out with new iPhones every year that are improved on the prior one. And a lot of times, scientists or engineers need to use math when they're developing their new technologies. So as we said before, here's an example of an engineer solving a real-world problem. For example, civil engineers are engineers that design solutions to transportation problems, such as needing to design a bridge. So the first thing that they do is they identify the problem. And the problem here, like in the picture of the Golden Gate Bridge, or maybe any type of bridge, is, hey, we need to get people across from one side of a body of water to another. So how can we do that? So the next thing they do is they investigate how others have solved the problem before them. So they go throughout history and say, well, what else has already been done? Do we need to invent something new, or can we build upon what other people have already found out or what other people have already made? Then they do research, and that kind of goes with the investigating piece. And finally, they carefully plan and calculate how to build their structure. So they figure out, well, what's the best type of structure to make? What can hold the most weight? What can be long enough? They also look at things like, what will it look like? Will it look nice? Does that matter? Okay. Then B, they must work within their constraints. And constraints are, and you can see it over here in green, they're limitations such as the laws of physics, materials, cost, safety, or environmental regulations. So for example, when these civil engineers are designing a bridge, they only have a certain amount of money that they can use. They probably only have access to certain types of materials or certain materials. I might want to build my bridge out of diamonds, but I'm probably not going to be able to afford that or get enough diamonds to make an entire bridge. They also have to look at safety. Laws of physics, is it even possible to create the type of bridge that we want? Will it even hold up? Will it hold people or cars or whatever we want it to hold? And then they often have to make trade-offs. They might say, well, I might give up what it looks like to make sure it's more safe. Or sometimes they have to trade off, I might give up an environmental piece, so maybe it might cause a little bit of pollution in order to make it be less expensive, okay? So they have to kind of give and take or find a middle ground where they can kind of compromise on what they want to do. What skills are needed for engineering design? So the engineering design process is a series of steps that leads to a new product, process, or technique. So engineers need the following skills. They need to be able to think creatively. They need to be able to think methodically. This means thinking in an organized way, which allows them to follow the design process completely and efficiently. They need to use math and models. They need to use technology, and they need to use science. So they need to understand how technology, math, and science work. All right? And over here on the side, we have the definition of prototype. It's the test model of a product. And the engineering design process, I know this is a little bit difficult to see. If you go into the other slideshow, you can see these. But the engineering design process isn't always a linear process. Sometimes you kind of go back and forth, much like the scientific method is. So when you start, the first step is usually to identify a need. So what problem are you trying to solve? The second step is to conduct research. So what else has been done in the past? What have other people designed? Do I need to come up with something from scratch, or can I use other people's designs and just improve on those? Okay. Then, do you have enough information? If you have enough information, you can move on. If you don't, you have to go back and do some more research. Then, you start to brainstorm solutions. So working together is the best way to come up with the best types of designs. And the reason for that is because people often have different viewpoints or might think differently. And maybe someone else will come up with an idea that you would have never thought of. And so they work together to come up with as many possible solutions as they can. Okay? And these aren't the final solutions, they're just ideas to try. Okay? Then they move on and say, do you have an idea worth trying? If you don't, then they need to go back and brainstorm more solutions. If they do, then they select a solution. Okay? Which of the ideas do you want to try? Pick one and plan how you want to try it. Okay? Can you make a prototype? So you would have to have enough materials to make a prototype or a sample. So if you can, then you move on. If you can't, you go back and have to brainstorm more solutions. Maybe you don't have the materials or the right amount of money to be able to create one. All right, then you build your prototype, and your prototype is a working model of your solution. So it might be smaller, it might be made with less expensive materials, but it's still going to work and have a similar function to your final product. Then you test and evaluate. Your prototype probably won't be perfect the first time, but it should be on the right track. Okay. So if your prototype shows promise, you can continue. If it doesn't, you have to go back and brainstorm more solutions and kind of start over. Okay. Then you redesign. What am I going to improve? What can I do to make my prototype better? Okay, and then you make those changes. Does the prototype work well? If it doesn't, you go back to brainstorming new solutions. If it does, you move on and communicate your results. So when your prototype is finished, you have designed a solution to your problem and tell others how you did it. And then you would share ideas with other people. And then you're at the end. So we're going to be using the engineering design process and looking at these different steps throughout the next week or so. So make sure you get everything finished in your notes.